सर ते टेक्निकल प्रॉब्लेम आहे काय आपल्या साईडने नाही काय नाही ते काय ते चालू आहे
Okay, good morning everyone. In yesterday's lecture, we started with one-dimensional wave equation. So in short, we'll just recall the partial differential equation governing the system of one-dimensional wave equation W2U by W t square is equal to c square W2U by W x square. The most general solution for this partial differential equation is C1 cos mx plus C2 sin mx, C3 cos of CMT plus C4 sin CMT. The boundary condition and the initial condition. So at initial point and at the final point u of L comma t, if the string is of length L, then the deflection at these 2 points will always be 0. And the boundary conditions are W by W t at t equal to 0 is 0. Initial velocity, in maximum examples it will be 0, or in some cases that can be some other function f of x. And u of x comma 0 is equal to g of x. Okay. Method. What was our method? We use the first condition u of 0 comma t equal to 0, and what we derive is c1 equal to 0. We'll use the third condition w by t at t equal to 0 equal to 0, then we'll derive that c4 equal to 0. Third case, then after that we use the condition w by t at t equal to 0 is equal to f of x, and by using that probably we will get the value of m, whatever it is. Okay. And the last one, u of x comma 0 equal to g of x. We'll use this condition to find bn. Okay, so this was the complete procedure. 2 examples we have already solved. In one example, the idea was use a Bn is equal to 2 by L integral 0 to L f of x sin n pi x by L dx. We use this formula to find out the Bn, and in the second example what we did was we compared left and right hand side. Compare left and right hand side. Fine. So this was everything that we have seen yesterday. So in today's lecture, we are going to go ahead with some different examples. So if W2u by W t square is equal to W2u by Wx square, represent the vibration of a string. Of a string of length of 1 unit, fixed at both ends, fixed at both ends. Find the solution with boundary conditions. First one, u of 0 comma t is equal to 0. Second, u of 1 comma t is equal to 0. Third one, w by t at t equal to 0 is equal to 0. And the fourth one, u of x comma 0 is equal to 2 times x minus x square. For 0 less than x is less than 1. So this is the complete question. And now once we identify that this is a wave equation, we'll start our solution with the most general solution. Yes, anyone who can tell me the most general solution in this case? Most general solution is, yes, anyone? Ruturaj? Tejas? Look, I'm going to remove you from the meeting if you don't respond. Be quick. What's the most general solution? Ruturaj, not there? Okay.
Sir,
Let me
C1
just
plus
say,
max plus
yes, what is the answer?
C1 cos mx plus C2 sin mx plus C3 cos CMT plus C4 sin CMT.
Sin mx, C3 cos CMT plus C4 sin CMT. Is there anyone who wants to make a change in this? This is not exactly correct. Let me remove the Ruturaj first. Yes, Tejas.
काय झालं
Not there.
हा मग काय एवढं डोक्यात आपल्याकडे असतात आहे का ते काय क्लिअर हा तर ते मला करा तुम्ही phone. हो. ते अमोलला सांगा अमोलची लॉजिक यूज केली
Chirag.
हा
Yes, sir. Yes, do you want to make a change in this?
थांबा ना प्रॉब्लेम ते सॉल्व्ह होऊ द्या एकदा. तो ते एकदम बेसिक होईल मुलांना वगैरे बोलू नका काय त्यात म्हणजे बेसिक प्रॉब्लेम आला एका वेळेस खूप मुलांनी लॉगिन केलं मला
Where is Janvi? Janvi, you want to make a change in this?
So I don't know. I wasn't there yesterday actually.
Aditya Goye.
हजार एक मुलांनी लॉगिन केलं बोलू नका काय मला माहित नाही हा ठीक आहे काय
Aditya.
C4 is 0.
Yes, what you said?
C4 is 0.
I want a change in the most general solution. Okay, if you could think, what does this C represent? What is this C?
काय चाललंय
Where does it come from?
आता हे कालचं एवढं काम करून मी बोलणं खावं लागलं वेगळं
Sir, is it C1 cos mx plus C2 sin mx into C3 cos sin t plus C4 sin mt?
Yes, exactly. So what do we observe here is the value of C comes from the differential equation. If your differential equation is equal to C square da by 2u by da by x square, then this C comes here. Okay. So this C comes from the differential equation. In this differential equation, the value of C is 1. And that's why we'll change this value of C over here. So what we get is C3 cos mt plus C4 sin
नाही असं नाही
MT.
का फॉलो नाही घेतलं त्यांना माझी लेक्चर झालं
Now.
त्यांना फोनही केला की तर काय झालं मीटिंगमध्ये मी 15 मिनिटात तर ते म्हणे काय नाही सर तुम्ही ऍड्रेस अपलोड केल्यानंतर त्यांनी अपलोड केलं त्याचं नाव कळवतात एवढंच पॉईंट होतं म्हणजे
U of 0 comma t is equal to 0. This will imply that, just like our remark,
काय तुम्हाला काय लिहून पाहिजे
C1 equal to 0. Then W by W t at t equal to 0. Then what you'll get is C4 equal to 0. I'll go for the second condition. U of 1 comma t is 0. So in that case, U of 1 comma t equal to 0. So C1 is 0, C4 is 0. So U of xt, what we have is C5 sin mx cos mt. So U of 1 comma t here will be C5 sin m cos of mt is equal to 0. Again, C5 and cos mt cannot be 0. Sin m is equal to 0, which implies that m equal to n pi, for n is running from 1 to up to infinity. So when we put this, U of xt will become summation bn sin n pi x to cos n pi, the value of c is 1, so n pi t, n is running from 1 to infinity. Now the last condition, U of x comma 0 is equal to 2 times x minus x square. This is equal to summation bn sin n pi x, and is running from 1 to infinity. So this is half range Fourier sine series.
बोला सर काय आता कसं होईल
So bn is equal to 2 by L. The value of L is 1. Integral 0 to 1, 2 times x minus x square sin n pi x dx. So this will become 4. Use the generalized UV rule. So x minus x square as it is. Integration of sin n pi x is minus cos n pi x on n pi, minus derivative of this 1 minus 2x. Integration of this once again, that will be minus sin n pi x upon n square pi square plus derivative of this once again, that will be minus 2, and in the bracket cos n pi x upon n cube pi cube, limits from 0 to 1. So I can rub this part now. When you put the upper limit, what do we get? 1 minus 1. The first term will become 0. In the second term, you will get sine n pi. So again it is 0. And in the third one, so 4 times in bracket minus 2 cos of n pi upon n cube pi cube minus, when you put the lower limit, first term is 0, second term is 0, and the third one cos 0 will become 1. So that is minus 2 upon n cube pi cube. So this is minus 8. Yes, anyone? Cos n pi equal to? Cube pi cube. So cos n pi is equal to minus 1 raised to n. Okay. How do you get this? You put n equal to 1, cos pi. Cos pi is minus 1. Put n equal to 2, cos 2 pi. It is 1. N equal to 3, cos of 3 pi is again minus 1. So it is actually following the pattern minus 1 raised to n. That's why I can replace cos n pi by minus 1 raised to n. So this is equal to bn. Hence the final solution
मी सांगतो एकही विषयाचे ज्ञान वेगळे चालतोय
the u of x comma t is equal to summation n is running from 1 to infinity 8 in bracket minus of minus 1 raised to n upon n cube pi cube cos n pi x cos n pi t.
मल्टिपल पेपर असतील पण सांगतो ना
Fine. The last question of this topic. Example. Dabba to u dabba to u by dabba x square, where u of 0 comma t is equal to 0, u of f2 comma t equal to 0. Third one, w by w t at t equal to 0 is 0. And the fourth one, u of x comma 0 is equal to 2x. Please do it. You have 5 minutes. So u of x comma t equal to c1 cos mx c3 cos amt plus c4 sin amt, which will certainly reduce to c5 sin mx cos amt. If 2 comma t is equal to 0, which will imply that m is equal to anyone.
So it is n pi by 2.
N pi by 2 exactly. So u of x comma t, combine all the solutions, summation bn sine n pi x by 2 cos n pi a t by 2. Now find out bn. And what is the final answer? Bn. Okay, anyways, it's up to you. You want to solve it, or leave it. I would have completed the syllabus in today's lecture, but I don't want to. I'll maximum I will need of more 2 lectures to complete the whole syllabus. Okay, just last heat equation is remaining. So now we will end here today. Put your name and roll number in the chat box. The wave equation is complete now. In next lecture, I will do the wave equation, heat equation, and again one lecture will have some examples on the heat equation, and I will introduce two-dimensional wave and heat equation also, and then we'll be done with our syllabus. But once we are done, I will be conducting a 20 marks test soon enough, probably in the next or next to next week. I don't know the schedule of your online exams or what practical exams, how those are going to be conducted. So whatever it is, so maybe next week Thursday will be fine for me. So is it okay with everyone? If no reply, I'll
Yes.
consider it and consider it yes, and we'll go ahead then.
Yes, sir. Yes, sir.
Next Thursday, 9:30 to 10:30, we'll have a test. The syllabus will be statistics, probability, and Laplace transform.
So MCQ.
Yes, MCQ. Now, 3 sets will be there, 3 paper sets, and you may randomly get a mail. And before I start the test, I'll share a Google Sheet on which you can enter your active email address. And on your email address, you will get the link. You will not know who is getting which set. And even in each set, I'll make the distribution separate so that there won't be any malpractices going on. So please study properly. Thank you, everyone.